Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. In today's video, we are going to learn and solve problems on consistency of a system of linear equations. See, the solution method for solving the consistency of a system of linear equation is similar to that of the Gauss elimination method, and that we have already learned in the previous video. So, if you haven't watched that video yet, then please go and watch it. It is very important to understand this concept further. Now, before moving on to solving the problems here, it is very important to understand the theory here, because it is similar to Gauss elimination method, but with some theory added to it. Okay, so if you don't understand the theory behind this, then you will end up writing the wrong answers and end up losing marks. So please pay close attention here and please don't skip any part of this. So let the system of linear equations be. I write equations here: a11 x1 plus a12 x2 plus a13 x3 is equal to a. Okay. Next, a21 x1 plus a22 x2 plus a23 x3 equals b, and a31 x1 plus a32 x2 plus a33 x3 equals what? C. Okay. Now, we do the same circus here what we did in Gauss elimination method. We write this in the form of A augment B. That means we write the augment matrix, the matrix A combined with the constants. Okay, it is A augment of B, it is A semicolon B equals A11, A12, A13 semicolon A, the matrix of A combined with the constants. Okay, then A21, A22, A23 B, and lastly A31, A32, A33 C. Okay, so we have this matrix here. Now, for this matrix, we apply the row transformation and find the rank. Okay, what's the next step? We write the augment matrix. After writing the augment matrix, we apply the row transformation, and from that we what? Find the rank. Okay, now here lies the thing, find the rank. Now understand this, see this, only this part will give me the rank of A, that is row of A. But this whole thing, that is this plus this whole thing will give me rank of A augment B, that is row of A augment. Getting it? Now, the whole theory lies behind these two ranks. So, the theory goes like this. First is, if rank of A augment B equals to rank of A, row means rank, okay, and that is equal to say n. If both the ranks are same, rank of this whole matrix is equal to the rank of this matrix, both are same, equal to n, where I will write n is what? Small n is number of variables. Number of what? Variables. It can be 3, 4, so on. So here in this case, x1, x2, x3 or xyz, 3 variables, okay, is equal to n. Then we say the system is consistent and it has unique solutions. That means there is a solution of each and everything, x1, x2, x3 or xyz, whatever, same as the Gauss elimination method. If it is consistent, then the solution is same as Gauss elimination, nothing, no difference at all. So what is that? The system is consistent and has a unique solution. Second case, if rank of A augment B equals to rank of A, and it is lesser than n. N is what? Number of variables. In that case also it is consistent, but it has infinite solution. Infinite solutions, many number of solutions. Okay, this we see solving the further problems if it occurs. Okay, then the third and last one is also if the rank of A augment B is not equal to rank of A, then what? Inconsistent, hence no solutions. So once again, lend a ears to me. You have the matrix, you find the argument matrix, you do the row transformation, you find a rank. Then the theory here, if the rank of this whole matrix is equal to rank of A, then consistent, but what? Unique solutions, same as cross elimination. But here, if the rank of A going to be is equal to rank of A lesser than n, say the rank is 2, number of variables are 3, then it is consistent, but what? Infinite, numerous number of solutions. Okay, and lastly, if rank of A augmented B is not equal to rank of A, then inconsistent, and we have no solutions. That's all. This is a theory you need to remember properly, and I have mentioned this in a very easy way, as I always do. Follow this theory, store it in your brains here, and apply to the problems, because if they ask consistency, inconsistency, you have to apply this theory right, otherwise they will cut the marks. Okay, so please see it, watch the video one more time and understand the theory first to move on to the problems next. So my dear students, I hope the theory is perfectly clear. Now let's move on to solving the problems. We have this problem has been asked in the model question paper of the fresh VTU syllabus. So I have taken it here now. So the problem is test for the consistency of the following system and then solve x minus 2y plus 3z is equal to 2, 3x minus y plus 4z is equal to 4, and 2x plus y minus 2z is equal to 5. So first let's write the system here. So again, be careful while taking down the problem from the question paper. If any value or numeric value or any sign goes wrong, your whole effort goes to waste. Okay. So please remember my words. So we write the matrix as x minus 2y plus 3z is equal to 2. Okay. So be careful here. I write z like this. Okay. Now 3x minus y plus 4z equals 4, and lastly 2x plus y minus 2z is equal to 5. So we have the system of linear equations here. So first step, what we do? We write the augmented matrix, that is, let's take it as A augment B equals, we have 1 minus 2, 3, semicolon 2, that's augment 2, then 3 minus 1, 4 and 4, and then 2, 1 minus 2 and 5. So this is the augmented matrix. Perfect. Okay. So now for this augmented matrix, we write the same circus we follow as we do in the Gauss elimination. We apply the row transformation. Okay, and here we try to find a rank here. So what's the operation here? I've been doing in this my previous videos of finding rank also, in the previous for Gauss elimination also. Please do refer them. Now I have the A augment B. So the first thing I need to do, make 2 0 making use of 1. See, please don't do this mistake. Always follow the correct steps to get the correct answer. Again I repeat, first make 2 0 making use of 1. Okay, then make 3 0 also making use of 1, then make 1 making use of this thing. Okay, first let's take this is the main person here, right, 1. So making use of this 1, I need to make this 3 and 2 0. First go from down. The steps which I follow are guaranteed to get the perfect answers. Okay, now what to do here? First make 2 0 making use of 1. So how can I make 2 0 making use of 1? This should be 2. So multiply the whole row R1 by 2. So 2 1s are 2, 2 into minus 2 minus 4, 2 3s are 6, 2 2s are 4. Okay. So, what's the operation here I follow? It is R3 minus 2R1. That is, I am making this R3 row 0, making use of the R1 row. So, this will be now 1 minus 2, 3 and 2 as it is, because matrix is multiplied by scalar or divided, it is even the same. Okay, then 3 minus 1, 4 and 4 as it is. Now, see this operation. I will do, I written it top here. I need to use this numbers 2 minus 4, 6 and 4. Okay, 2 minus 2, 0. Okay, that is my main aim, to make this 2 0. Done. Now, similarly, the same operation will be applied to the row R3. 1, be careful here. 1 minus, the operation is minus 2 R1. So, 1 minus of minus 4 plus 4. So, 5. Minus 2 minus 6 minus 8. And lastly, 5 minus 4 is 1. Okay. Next, you need to make 3 0 making use of 1. Okay. So, first this is over done. Now, you need to make 3 0 making use of this one only. So, again LCM is 1 3 is 3, 3 minus 3 0. So, multiply the whole row by 3, 3 1s are 3, 3 2s are minus 6, 3 3s are 9, 3 2s are 6. So, we have R2 minus 3 R1. So, this will be now 1 minus 2, 3 and 2 as it is. 3 minus 3, 0. Again here see, minus 1 minus 1 minus plus 6 will be 5. Be careful here, again see, minus 1 operation is minus. So, minus 1 minus a bracket minus. So, minus 2 minus become plus 6. So, minus 1 plus 6 is 5. Now, 4 minus 9 is minus 5 and 4 minus 6 is minus 2. Correct? Again, this as it is 0, 5, minus 8 and 1. Okay, now the next thing is what? You need to make this 5. See, this work is over. By using this 1, I made this 0. Now, next column, next is 5. By making use of this 5, only below this 5, I have to make this 5 0. And it is very, very easy, because 5 and 5 both are same. So, we do R3 minus R2 directly. So, we have A augment B equals here 1 minus 2, 3 colon 2 as it is, then 0, we have 5 minus 5 and yeah, minus 2 as it is. Lastly, 0, 5, minus 8 and 1 as it is. Done. Okay, now I'll apply the operation here. Sorry. So, what is the operation? R3 minus R2. So, 5 minus 5, 0. Done. Minus 8, minus 8, minus of bracket minus 5. So, minus 8 plus 5 will be minus 3. And lastly, 1 minus of minus 2 plus 2 will be what? 3. That's it. So, we have it now. Okay. So, we apply the row transformation. My aim was to make below this one 2 0 and below this 5 0. So, all the principal diagonal elements are what? Below the principal diagonal elements are 0. That is a Gauss elimination method as it is. Now, we see here, as I told you, see this whole is what? A. Right? It gives the rank of A as we discussed in theory, and the whole along with this whole thing will give the rank of A augment B total. Fine. So, now if we see here, theoretically, here see, what is the rank of A? Rank of A equals 3, right? See, what is meaning of rank? Highest number of non-zero rows, 1, 2, 3 rows. So, there is no full complete 0 row here. So, 1, 2, 3 rows are 3, rank is 3. Similarly, A augment B, full whole thing, again 1, 2, 3. Again, this also rank of A augment B is how much? 3 only. Therefore, we can write rank of A equals rank of A augment B equals 3, that is equal to the number of variables n. That is x, y, z, 3 variables, that is n. That's it. Therefore, I write here rank of A is equal to rank of A augment B, that is equal to 3. That means it is what? Consistent and consistent, right here consistent and unique solutions. See, the theory is important here. Consistent and unique solutions. Therefore, unique solution is what? All x, y, z, all will have solutions. It is, that's why I told you the solution is same as Gauss elimination, but this theory has to be included here. What theory? Rank of A is equal to rank of A argument B, that is equal to 3 is equal to N. So, consistent and unique solution. It's so easy. And see, I am making here each and everything very, very easy for you, so that each and every student of engineering, that is VTU engineering, has to clear M1, M2, M3, M4 easily. So, please don't keep these videos to yourself, share it with your friends and classmates as much as possible and do the good work, so that each and everyone gets benefited from this videos and pass the examination. That's what I wish. Okay, and if you are new to this channel, please do subscribe. Now, we have it as consistent and unique solution. See, then solve. They mentioned then solve. Okay, they given here and then solve. We have to solve them. Solve means we need to find a value of x, y, z. So, simple as that. So, we know that this is for x, this is y, and this is z. I write here if you want. This is for x, this is y, and this is what? Z. So, see the last row here, 0x, x equal to 0, 0x, 0y, minus 3z equals 3, because this whole system represents a equation type. Okay. Now, minus 0, 0 and only z is there. So, we have minus 3z is equal to 3, correct. So, z is equal to how much? Minus 1. That's it. So, we have z is equal to minus 1. Okay. Next one is what? Put it second row. What is second row? 5x, 5y, sorry, 5y. See this 0x and 5y minus 5z is equal to minus 2. So, 5y is equal to minus 2 plus 5 into z. So, minus 2 plus z is how much? Z is minus 1. So, 5 into minus 1 is again minus 5. That is equal to minus 7. See, 5y is equal to minus 7. So, y will be equal to minus 7 by 5. Okay. So, we have y as minus 7 by 5. Now, put this value here in first equation. See, what is that? 1x, that is x minus 2y. I hope you are getting it now. See, yes, this row for x, column for x, column for y. So, minus 2 into y, minus 2y, 3 into z, 3z equals 2. So, x will be equal to 2 plus 2y minus 3z. So, that is nothing but 2. See, 2 into y. Y is how much? 7 by 5. 2 into 7 by 5 root 14 minus 14 by 5. I am writing directly, and minus 3 into z. What is that? Minus 1. Minus 3 into minus 1 is plus 3. So, the LCM here is 5. So, x will become now, see, LCM is 5 means it will be upon 5. That means x is equal to whole divided by 5. You can take the LCM here. 5 is 15 and 10 is 25. Yeah, it is 11 by 5. That's all. Okay. So, verified x is how much? 11 by 4. That's it. These are the solution. Therefore, we have the solution as x is equal to how much? So, what is right? The system is consistent and an has unique solution, and a solution and the unique solutions are x is equal to 11 by 5, y equals minus 7 by 5, and lastly z equals minus 1. That's the solutions. That's it. That's how it is done. Okay. So, same as Gauss elimination plus little bit of theory involved, but one more thing, to make it more perfect and get the full marks, you need to practice it. And also see, there are some more questions. Okay, see, one is unique solution, consistent unique solution. Other one is what? Consistent infinite solutions. So, I will be solving those problems of infinite also in the further videos. So, please stay tuned. If you are new, please subscribe. If you have any comments or if you want me to solve any other questions from matrices or any other topics in M1, M2, M3, M4, please drop a comment below. So, that's all in today's video. See you in the next video. Till then, happy engineering. Bye.